वेरी गुड मॉर्निंग क्लास। सो लास्ट टाइम हम डिस्कस कर रहे थे टॉरेसिलीज थ्योरम और वेंचुरीमीटर. सो टुडे वी विल डिस्कस सम क्वेश्चन बेस्ड ऑन कंटिन्यूटी इक्वेशन एंड Bernoulli's theorem. So here the first question is, the cylindrical tube of a spray pump has a cross section of 8 centimeter square, one end of which has 40 fine holes, each of diameter 1 millimeter. If liquid flow inside the tube is 1.5 meter per minute, what is the speed of ejection of liquid through the holes? So let us consider we have a cylindrical tube here, and these are the two ends mentioned in the question. According question, the liquid is getting inside from this end and is coming out from this end from 40 fine holes. Here we have 40 fine holes, each of diameter 1 mm. For outflow, we will take area of fine holes. So here, according question, what is the data? The area of the cross section is 8 centimeter square. So here A1, through which the water is getting inside or fluid is getting inside, is 8 centimeter square. One end of which has 40 fine holes, यानी कि n is equal to 40. Diameter of each hole is 1 mm. So D is equal to 1 mm. So we can write it as 1 into 10 raised to the power minus 1. So this is D, and radius will be equal to 1 by 2 into 10 raised to the power minus 1 centimeter. Now, if the liquid flow inside the tube is 1.5 meter per minute, it means the liquid is getting inside this tube through this cross section with a speed of 1.5 meter per minute. So V1 will be equal to 1.5 meter per minute. We will convert all data in the CGS system. So here it will be 1.5 meter, multiply it by 100, so it will be in centimeter, and it is per minute, so we will convert it into second, so it will be centimeter per second. So A1, V1, this is the number of fine holes, this is the radius of the each fine hole. Now according continuity equation, A1 V1 is equal to A2 V2, where A1 is the cross sectional area through which the liquid is getting inside, V1 is the velocity with which it gets inside, A2 is the cross sectional area through which the liquid gets outside, and V2 is speed from this area. So here A1 is 8 multiplied by V1 is 1.5 multiplied by 100 divided by 60. That should be equal to A2 will be area of 40 fine holes. So 40 multiplied by area of one hole, that will be pi r square. So we will take it as 22 over 7 multiplied by r is 1 by 2 multiplied by 10 raised to the power minus 1 centimeter. So it will be r square 1 by 2 multiplied by 1 by 2 multiplied by 10 raised to the power minus 2 multiplied by the velocity of ejection. So it is V2. We have to calculate V2. So it will be 8 multiplied by 15 over 6, that will be equal to 40 multiplied by 22 over 7 multiplied by 1 by 4 multiplied by 10 raised to the power minus 2 V2. If you calculate this all, you can see that velocity of ejection will be 63.63 centimeter per second. So this is the answer. Now the second question is, water flows through a pipe whose internal diameter is 2 centimeter at a speed of 1 meter per second. Here we have a cross-sectional area corresponding to which this is the velocity. What should be the diameter of nozzle if the water is to emerge at a speed of 4 meter per second? Here we have the speed of ejection and we have to find the cross-sectional area through which the flow of the liquid is 4 meter per second. So D1, that is the diameter of the cross section through which the liquid is getting inside, that is 2 centimeter. So we can convert it into the meter. So it will be 2 into 10 raised to the power minus 2 meter. So radius will be 1 into 10 raised to the power minus 2 meter. The velocity with which the liquid gets inside, that is 1 meter per second. Now here we have the speed of ejection V2, that is 4 meter per second. According continuity equation, A1 V1 that will be equal to A2 V2. Here A1 will be pi R1 square multiplied by V1 is equal to A2. We have to calculate A2 multiplied by V2. Now put the values. It will be 22 over 7 multiplied by R1 is 10 raised to the power minus 2. So R1 square will be 10 raised to the power minus 4 multiplied by V1, that is 1 meter per second, is equal to A2 multiplied by V2 is 4. So simply we can see A2 will be equal to 22 over 28 multiplied by 10 raised to the power minus 4 meter square. So you can calculate it and convert it into the centimeter square. Now the third question is, water flows through a horizontal pipe of varying cross section at the rate of 20 liter per minute. Determine the velocity of water at a point where the diameter is 4 centimeter. So again we have to find the velocity of ejection. So in this case, water flows through a horizontal pipe of varying cross section at the rate of 20 liter per minute. So this is the speed with which the liquid gets inside. So V1 is 20 liter per minute. So we can convert it into the meter cube. Basically this is the 20 liter per minute. So this is the volume. So volume will be area multiplied by the velocity, or the area multiplied by the liquid getting inside in unit time. So it will be A1 V1. So 20 liter per minute. So it will be 20 into 10 raised to the power minus 3 meter cube over, this is the minute, so it will be 60 seconds. As you know, A1 V1 is equal to A2 V2. So we have to calculate the velocity of ejection. It implies that V2 is equal to A1 V1 over A2. In this case, the diameter of the cross section through which the liquid gets outside is 4 centimeter. So D2 is 4 centimeter. So R2 will be 2 centimeter. It implies that A2 that will be equal to pi R2 square. So it will be 22 over 7 multiplied by 4. So 88 over 7 centimeter square. That is the area of second cross section. We will convert it into the meter square. So it will be 88 over 7 multiplied by 10 raised to the power minus 4 meter square. Now A1 V1 is equal to this one. So V2 is equal to 20 into 10 raised to the power minus 3 divided by 60 multiplied by 1 over A2, that will be 7 over 88 multiplied by 10 raised to the power minus 4. Now V2 will be equal to, now you can calculate this one, and after calculating you will get the answer 0.26 meter per second. That is the velocity of ejection. Here the fourth question is, water enters into a horizontal pipe of varying cross section at the speed of 0.5 meter per second. This is the velocity of with which the liquid gets inside, and speed of outflow is 0.7 meter per second. This is the speed with which the liquid gets outside. The pressure at the first end is 10 raised to the power 3 Newton per meter square. Calculate the pressure at the second end. So this is the case. This is a horizontal tube. The liquid is getting inside with a speed of 0.5 meter per second, and here the speed of ejection is 0.7 meter per second. If the pressure at this end is 10 raised to the power 3 Newton per meter square, you have to calculate the pressure at this end. So this is the case or question based on the Bernoulli's theorem. So as you know, first we will write the value given here. So V1 is 0.5 meter per second, P1 is 10 raised to the power 3 Newton per meter square, V2 is 0.7 meter per second. As you know that in the question it is given that the tube is horizontal. So according Bernoulli's theorem, P1 plus 1 by 2 rho V1 square plus rho G H1 is equal to P2 plus 1 by 2 rho V2 square plus rho G H2. As the tube is horizontal, so H1 will be equal to H2, and these two terms will cancel out. So we will have P1 plus 1 by 2 rho V1 square is equal to P2 plus 1 by 2 rho V2 square. So as you can see that V2 is greater, so we will transfer this term here. So P1 minus P2, that will be equal to 1 by 2 rho V2 square minus V1 square. Now P1 is 10 raised to the power 3 minus P2 is equal to 1 by 2 rho, that is the density of water, 10 raised to the power 3 multiplied by V2 square, that will be square of 0.7 minus V1 square, that is the square of 0.5. So by calculating it, you can calculate the value of P2, and the answer is P2 is equal to 1.120 into 10 raised to the power 3 Newton per meter square. So this is the solution. So that's it for today. In the next class we will do the next topic, that is the surface tension. Thank you.